in this short video we will discuss about the gamma function and the beta function. So this improper integral 0 to infinity e power minus x to the power n minus 1 dx, this improper integral is convergent for n greater than 0. This improper integral is convergent for n greater than 0, and hence this is what is the gamma function. It is denoted by gamma n. So gamma n is nothing but integral 0 to infinity e power minus x times x power n minus 1 dx. This is the gamma function. This is known as the gamma function. So now there are certain properties of the gamma function which I will only state. We will not prove them because what we will focus on is the application part. We will apply these properties in order to solve other problems, but we will not prove them. So the first important property is gamma 1. So gamma 1 is equal to 1. Remember that gamma 1 equals to 1. This is very easy. In this improper integral, if you put the value of n equals to 1, then you can easily calculate it and you will get the value of 1. So the first property is gamma 1 equals to 1. Second important thing is gamma n plus 1. Gamma n plus 1 equals to n gamma n. Gamma n plus 1 equals to n gamma n. Third important property is gamma n plus 1 equals to n factorial. Gamma n plus 1 equals to n factorial. The fourth important property is gamma n times gamma 1 minus n. Gamma n times gamma 1 minus n, this is equal to pi divided by sin n pi. Pi divided by sin n pi. This is what the fourth important property is. Now the fifth important property is gamma half. What is the value of gamma half? Remember that gamma half equals to root of pi. So these are the 5 important properties that we have. So now using them we will solve some problems. So the first problem that we have is, so the first question is evaluate gamma 11 by 2. So to calculate this we will use this property, that is gamma n plus 1 equals to n gamma n. With the help of this we can solve this problem. So let me write it, gamma n plus 1, this is equal to n gamma n. With the help of this we will solve this. So 11 by 2 can be written as 11 by 2. This 11 by 2 can be written as a sum of 1 plus 9 by 2. Similarly 9 by 2, this can be written as sum of 1 plus 7 by 2. Like this we will break this and calculate the value of gamma 11 by 2. So gamma 11 by 2 equals to n times gamma n. So what will be n in this case? If I break it and write it like this, gamma 11 by 2, this is equal to 1 plus n by 2. So gamma 11 by 2 equals to gamma 1 plus n by 2. If you compare this and this, the value of n is 9 by 2. Hence I can write this further as 9 by 2 times gamma 9 by 2. I hope this is clear. You can see gamma 11 by 2 equals to gamma 1 plus 9 by 2, because 11 by 2 can be written as 1 plus 9 by 2. Now why I have written it in this way? Because 1 plus n, gamma 1 plus n equals to n gamma n. Hence in this case if I compare this and this, the value of n turns out to be 9 by 2. Hence I can write this as 9 by 2 times gamma 9 by 2. So this I will continue doing. So this can be further written as 9 by 2 times gamma. So what is 9 by 2? 9 by 2 is 1 plus 7 by 2. 1 plus 7 by 2. So what will this become? 9 by 2 times, so again this is gamma 1 plus n. Gamma 1 plus n equals to n gamma n. What is n in this case? N in this case is 7 by 2. So this becomes 7 by 2 times gamma 7 by 2. So I hope you are getting the pattern by which this is being calculated. Again 7 by 2 can be written as 7 by 2. What is 7 by 2? 7 by 2 is 1 plus 5 by 2. So again I will use this, gamma 7 by 2 equals to gamma 1 plus 5 by 2, which is further equals to n gamma n. N in this case is 5 by 2. So again 5 by 2 gamma 5 by 2. This is what is gamma 7 by 2. Gamma 7 by 2 is this. So again if I break 5 by 2, what I will get? 5 by 2 can be written as 1 plus 3 by 2. So 5 by 2 equals to 1 plus 3 by 2. So gamma 5 by 2 equals to gamma 1 plus 3 by 2, which can be further written as 3 by 2 gamma 3 by 2. Again, what can I write as 3 by 2? 3 by 2 can be broken down into 1 plus half. Hence, gamma 3 by 2 equals to gamma 1 plus half, which is equal to half gamma half. So now we have reached a stopping point. So if I put all of this into this form, what I get is 9 by 2 into, the expression stands out to be 9 by 2 into 7 by 2 into this term. So what is gamma 7 by 2? Gamma 7 by 2 is this. So into 5 by 2 into 3 by 2 into 1 by 2 times gamma half. This is what I get. I hope this is clear. In place of gamma 7 by 2, I have put this entire thing. Again, in the place of gamma 5 by 2, I have put this entire thing. In the place of gamma 3 by 2, I have substituted this entire thing. Now I have nothing to substitute with gamma half. But if you look closely, the properties that I have discussed, gamma half is already known. It is root pi. So what will this be equal to? This will be equal to 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into half into root pi. So if you do the entire thing, you will get 945 divided by 32 times root pi. This is the value of this gamma 11 by 2. So we will solve more problems. So the second question asks, evaluate gamma 7. So this is very easy. We know that gamma n plus 1, what is this? This can be written as n factorial. I have shown this in the property. You have seen over here, gamma n plus 1 equals to n factorial. We will use this over here to solve this problem. So gamma n plus 1 is n factorial. In this case, I can write gamma 7 equals to gamma 1 plus 6. So this will be equal to 6 factorial. So what is 6 factorial? 6 factorial is simply 720. So this is the value of gamma of 7. So this next question asks, evaluate gamma 1 by 3 times gamma 2 by 3. So to solve this one, we will use this property, that is gamma n times gamma 1 minus n equals to pi divided by sin n pi. So if we do this, what we will get is, let me write it over here, gamma n times gamma 1 minus n. This is equal to, what is this? This is equal to pi divided by sin n pi, divided by sin n pi. So we will use this. If you see, I can write this as gamma 1 by 3 times gamma 1 minus 1 by 3, because what is 1 minus 1 by 3? 1 minus 1 by 3 is 2 by 3 and this is 1 by 3. So I have just written the same expression in a different manner so that I can compare with this one. If I compare both of these now, I can see that the value of n is 1 by 3. So this can be further written as pi divided by sin 1 by 3 times pi. So what will this to be equal to? This will be equal to pi divided by, what is sin pi by 3? Sin pi by 3 is root 3 by 2. So this is equal to 2 pi by root 3. This is what we have. So this expression is equal to 2 pi by root 3. Integral 0 to 1 x power m minus 1 times 1 minus x whole power n minus 1 dx. This integral for values of n greater than 0. For values of n greater than 0 is convergent, and this is known as the beta function, which is beta m comma n. Hence beta m comma n equals to integral 0 to 1 x power m minus 1 times 1 minus x power n minus 1 dx. This is the beta function. So just like the gamma function, for the beta function also we have some important properties. So we will not prove the properties, rather we will see them and use them to solve some problems. So the first important property is the symmetric property. This is known as symmetric property. Beta m comma n, this is equal to beta n comma m. So beta m comma n equals to beta n comma m. This is known as the symmetric property. This is known as the symmetric property. So the next important property is the beta function, that is beta m comma n. This can also be written as integral 0 to infinity x power m minus 1 divided by 1 plus x power m plus n dx. This is another way of writing beta m comma n, which is further equal to integral 0 to infinity x power n minus 1 divided by 1 plus x whole power m plus n dx. This is another way of writing beta m comma n. So the third important property is beta m comma n can be written as, this is equal to 2 times integral 0 to pi by 2 sin 2m minus 1 theta times cos 2n minus 1 d theta. This is how we can write beta m comma n. Beta m comma n equals to 2 times integral 0 to pi by 2 sin 2m minus 1 theta times cos 2n minus 1 theta d theta. This is another way of writing beta m comma n. So now at last we have another very important property. The fourth property is the relationship between the beta function and this gamma function. The last property is the relationship between the gamma function and this beta function. So this is equal to beta m comma n can be written as gamma m times gamma n divided by gamma m plus n. This is how we can write beta m comma n. Beta m comma n equals to gamma m times gamma n divided by gamma m plus n. So now again let's solve problems to better understand all these. So this problem asks evaluate beta 4 comma 2. So we have seen that in the properties the relationship between beta and gamma function, beta m comma n equals to gamma m times gamma n divided by gamma m plus n. Hence we can write this as gamma 4 multiplied by gamma 2 divided by gamma 6. This is what we can write this into. So hence if I expand this, what I will get is, what is gamma 4? So I have shown in the above properties that gamma n plus 1 equals to n factorial. Hence what will be gamma 4? So with this logic, gamma 4 equals to, what is gamma 4? 1 plus 3, gamma 1 plus 3, which is equal to 3 factorial. So we will use this to calculate the problems. That is, whenever we have gamma of some number, that is gamma 4, gamma 5, it will be simply that number minus 1 factorial. Gamma 4 is 3 factorial, gamma 6 will be 5 factorial, like that. So we can easily solve this problem now. What is gamma 4? Gamma 4 is 3 factorial. What is gamma 2? 1 factorial. What is gamma 6? 5 factorial. If I expand this, 3 into 2 into 1 divided by 5 into 4 into 3 into 2 into 1. So 3 into 2 cancel, 3 into 2 cancel. This is simply 1 by 20. This is what we have. So this next question states evaluate integral 0 to pi by 2 cos 6 theta d theta. So we will do this using the beta function. First what we will do is, in the above properties I have stated that beta m comma n, this can be written as, beta m comma n can be written as 2 times integral 0 to pi by 2 times sin 2m minus 1 theta cos 2n minus 1 theta d theta. This is how I can write beta m comma n. Now if I want to represent this into the beta function, what I have to do is I have to compare these powers. So if I compare power of sine, here I don't have any sine term. Hence what will be 2m minus 1? 2m minus 1 will simply be 0. So what will be the value of m? M will be half. So this is the value of m. So this can be written as beta half comma, now the n part. So if I compare the power of the cos theta, 6 equals to, this is given as 6. So 6 will be equal to this 2n minus 1. So what will the value of n? N will be equal to 7 by 2. So this will be 7 by 2. So this I can represent with the help of beta function as beta half comma 7 by 2. Now I have to simply solve this beta function. Another thing is, here I have a 2 over here. So in order to represent this in the beta function, beta form, I have to divide this with 2. So this will be half. I hope this is clear, because I have a 2 over here. Hence if I want to represent this into the beta form, in form of the beta function, I have to divide this with 2, because I have a 2 in the formula over here. So now I have to find half beta half comma 7 by 2. So let me write it over here. This is what I have to calculate, half beta half comma 7 by 2. So now another important formula that I have shown in the properties section is that how to represent any beta function in form of gamma function. So beta m comma n can be written as gamma m times gamma n divided by gamma m plus n. This is how I can write the beta function. So this I can write as half times. So half times what is gamma m? Gamma half in this case, and gamma 7 by 2 divided by gamma m plus n. So 7 by 2 plus half is 8 by 2, which is nothing but gamma 4. Now we have to simply solve this. So if you know the value of gamma half equals to root pi, this I have stated in the above properties. Gamma half equals to root pi. So now what is gamma 4? Gamma 4 equals to 3 factorial. I have said that gamma 1 plus n, this can be written as n factorial, hence gamma 4 is 3 factorial. So I know this. Now how to calculate gamma 7 by 2? This is also very easy. Gamma n plus 1, this is equal to n gamma n. This is how we will reduce gamma 7 by 2 into a solvable form. So gamma 7 by 2, this can be written as gamma 1 plus 5 by 2, because I am just writing 7 by 2 as 1 plus 5 by 2. This is the same thing. So this equal to n gamma n. What is n? N in this case is 5 by 2. If you compare this with this, n is 5 by 2. So this will be 5 by 2 times gamma 5 by 2. So now again we will do the same thing for this. 5 by 2 times gamma 5 by 2. So 5 by 2 can be written as 1 plus 3 by 2. So this is equal to 5 by 2 times 3 by 2 times gamma 3 by 2, because 1 plus 3 by 2 is 1 plus n. What is n? N is 3 by 2. So n gamma n 3 by 2 times gamma 3 by 2. Now what is gamma 3 by 2? So let me write the entire thing again. 5 by 2 times 3 by 2 times. So what is gamma 3 by 2? Gamma 3 by 2 can be written as 1 plus half. Gamma 3 by 2 can be written as 1 plus half. Now again 1 plus n. So what will be gamma 1 plus n? N gamma n. So 5 into 3 by 2 into 2 into what is 1 plus, so this will be 1 plus gamma 1 plus half will become half gamma half. So I know the value of gamma half. What is gamma half? It is root pi. Hence this will become 5 into 3 into 1 divided by 2 into 2 into 2 root pi. This is what we will have. So now what will this become? So now what we will do is we will put the values in this expression. So let me do it separately over here. Half into, I am writing this expression, this entire expression in the bottom. So half into what is the first term that I have? Gamma half, which is root pi. So here I will have a root pi. So multiplied by what is the next term? Gamma 7 by 2. What is gamma 7 by 2? Gamma 7 by 2 is this. I have just derived this. 5 into 3 into 1 times root pi divided by 2 into 2 into 2. Next what do we have? The next thing is gamma 4. What is gamma 4? 3 factorial. So if I put it in the denominator, I have 3 into 2. That is what 3 factorial is. So what will this become? If I simplify this entire thing, this will become, so this 3 gets cancelled. So what do we have in the numerator? 5. Root pi into root pi will just become pi divided by 1, 2. So we have 2 to the power 1, 2, 3, 4, 5. What is 2 to the power 5? Nothing but 32. So 5 pi by 32. So the value of this expression cos 0 to pi by 2 integral cos 6 theta d theta, this is nothing but 5 pi by 32. So the next problem says find integral 0 to pi by 2 root tan x dx. Again we will take help of the beta function to solve this. If I simplify this a little bit, that is if I bring this in terms of sin theta and cos theta, what will I get? So this will become root sin x by root cos x dx. That is root tan x. I am writing this root sin x by cos x dx. So this will be equal to integral 0 to pi by 2. Now sin to the power half x times cos to the power minus half x dx. This is how I can write this thing. Now what we will do is we will represent beta function, which is beta m comma n. What is this? This is 2 integral 0 to pi by 2 sin 2m minus 1 theta times cos 2n minus 1 theta d theta. This is what we have to compare with. So if I compare the powers of this and this, what will I get? So 2m minus 1 equals to half. What is m? 2m minus 1 equals to half. What will be the value of m? M will be equals to, what is half plus 1? 3 by 2 divided by 2. So 3 by 4 is the value of m. Now similarly 2n minus 1, what will this be equal to? This will be equals to minus half. So this is minus half. So what is the value of n? N equals to half by 2, 1 by 4. So I have found out the value of n as 1 by 4, m as 3 by 4. So this root 10x dx, that is integral 0 to pi by 2 root 10x dx, this can be represented as half. Why I am putting this half? Because I have a 2 over here. So if I represent this in terms of beta function, this 2 will go down. I will have beta function, some beta value divided by 2. So beta half times beta, what will be m? M is nothing but 3 by 4. I have calculated m as 3 by 4 and n as 1 by 4. So 3 by 4 comma 1 by 4. So this is what we have to actually calculate. So let's do this. So what is what we have to calculate? Half times beta 3 by 4 comma 1 by 4. So we will represent this in terms of the gamma function. So this will be equals to half times gamma 3 by 4 times gamma 1 by 4 divided by gamma m plus n. So what is 3 by 4 plus 1 by 4? Simply 1. So this is what we have to solve. So now if you remember, what is the value of gamma 1? Gamma 1 is simply 1. Now another important thing is, what is gamma n times gamma 1 minus n? I have said in a property that gamma n times gamma 1 minus n, this is equals to pi divided by sine n pi. So we will try to put this in this form. So this I can write as this. I can rewrite this over here. Gamma 3 by 4 times gamma 1 by 4. Gamma 1 by 4 times gamma 1 minus 1 by 4, because 3 by 4 is nothing but 1 minus 1 by 4. So if I compare this and this, what is the value of n? N is 1 by 4. So this is simply equal to pi divided by sine pi by 4. So what is sine pi by 4? 1 by root 2. So this is root 2 times pi. This is the value of this thing. So now what we have is, I know this value is root 2 times pi. So what will this entire thing be? This will be equal to half times root 2 times pi. This is root 2 and 2 will get cancelled. So we will have pi by root 2. So this will be the value of integral 0 to pi by 2 root 10x dx. It is nothing but pi by root 2. So we have seen a lot of problems. Also what we have done is, we have seen what beta function is and we have also seen what gamma function is. So let's keep this video short. I hope this video has helped you. Thank you.